On April 17th of this year, data was released that could completely change our understanding of space. Scientists are reeling after the James Webb Space Telescope discovered what many are calling a planet with a 99.7% chance of life. This isn't just a major discovery. It would rewrite everything we know about our place in the cosmos. The claim is staggering, a world potentially more suitable for life than Earth. If this is true, then right now there may not just be life out there, but a thriving ocean of biological diversity. But what is the truth behind this incredible claim? Today, we break down the science, follow the evidence, and reveal the stunning reality. The answer is more complex and frankly more exciting than you can imagine. To understand what's happening, you have to know that the James Webb Space Telescope, or JWST, is the most powerful observatory ever built. Its ultimate goal is to find signs of life on other worlds. So, every time it sends back data, the world holds its breath. And the 99.7% chance of life claim seems to have emerged from two separate but equally fascinating discoveries. The first is a planet called K218b, located 124 light-years away. It's a prime target. Initial observations suggest that it could be a high-ocean world, a planet larger than Earth, covered in a deep liquid water ocean under a thick hydrogen atmosphere. These are fantastic candidates for life, and recently, Webb made a tantalizing detection in its atmosphere, a molecule called dimethyl sulfide, or DMS. On Earth, DMS is overwhelmingly produced by life, specifically marine life like phytoplankton. The hint of this molecule was enough to send shockwaves of excitement through the world. But where does that very specific number, 99.7%, come from? This involves a completely different planet, TWA7b. The discovery, published in the prestigious journal Nature, was a monumental achievement. For the first time ever, JWST captured a direct image of a brand new exoplanet. It's like trying to spot a firefly next to a searchlight from hundreds of miles away. In the scientific paper, researchers stated their certainty that the dot of light was a planet, calculating only a 0.34% chance it was a distant galaxy. And there it is, a 0.34% chance it's not a planet means a 99.66% chance that it is a planet. Round that up and you get 99.7%. Somewhere, the 99.7% chance of being a planet was twisted into the far more sensational 99.7% chance of life. So we have one planet with a potential biosignature and another with 99.7% confidence that it's a planet. The internet combined them to create a legend. The truth is more nuanced. To appreciate what these discoveries really mean, we need to understand the journey that brought us here. For most of history, the idea of exoplanets, planets orbiting other stars, was pure science fiction. The breakthrough came from seeing a planet's effect on its star. One of the first techniques was the radial velocity method. A planet's gravity makes its star wobble, and by measuring the tiny shifts in the star's light, astronomers could find an unseen planet. This is how the first exoplanet orbiting a sun-like star, 51 Pegasi b, was discovered in 1995. Her discovery, so revolutionary, it earned a Nobel Prize, but this method found massive hot Jupiters, not the Earth-like worlds we dreamed of. The next great leap was the transit method. If a planet passes in front of its star, it causes a tiny dip in the star's brightness. To see this, you need a telescope that can stare at thousands of stars constantly and patiently. That telescope was Kepler. In 2009, NASA's Kepler Space Telescope launched. It was a game changer. It stared at one patch of sky for years, and what it found was astonishing. Planets weren't rare, they were everywhere. Kepler revealed there are more planets than stars in our galaxy. Suddenly, the cosmos was teeming with new worlds. Kepler's data helped define the habitable zone or Goldilocks zone, the region around a star where liquid water could exist. But Kepler could only tell us where to look, not what those worlds were like. For that, we needed to go beyond just finding planets. We needed to analyze them. That's where Hubble gave us our first glimpses into alien atmospheres. But Hubble was limited. We needed a new observatory, one so powerful could dissect the starlight passing through their air, hunting for the chemical fingerprints of life. We needed a machine that could see the invisible. We needed the James Webb Space Telescope. So, how does Webb pull this off? It uses a truly impressive method, transmission spectroscopy. Every time a planet passes in front of its star, a tiny fraction of the starlight filters through its atmosphere. The atmosphere acts like a filter, with different molecules absorbing specific colors of light. When the light reaches JWST, it's missing these colors, creating a unique barcode. Water has one barcode, methane has another. By reading this barcode, scientists can identify exactly what gases are in that alien sky. It's an act of cosmic forensics from trillions of miles away. This is where the search gets interesting. Scientists are looking for biosignatures, combinations of gases that are hard to explain without biology. On Earth, oxygen and methane exist together only because life is constantly replenishing them. Finding that specific unbalanced cocktail on another world would be a powerful sign that something biological is at work. This is how Webb studied K-18b. But for the other planet, TWA7b, Webb used a completely different and far more challenging technique: direct imaging. A planet is billions of times fainter than its star, lost in the glare. To solve this, Webb uses a coronagraph tiny mask inside the telescope that blocks the star's light. It's like using your thumb to block the sun. Once the blinding light is gone, the planet's faint glow can be revealed. This is exactly what the team studying TWA7b did. After extensive image processing, a faint dot of light appeared right where they predicted a planet should be. This was a landmark achievement, but it's crucial to remember what this was: a technical triumph, not the discovery of a habitable world. Now, let's peel back the hype and look at what the science actually says. First, K-18 billion, the planet that sparked the frenzy. It's about 8.6 times the mass of Earth, orbiting its red dwarf star in the habitable zone. In 2023, JWST observations, led by Professor Niku Madhusudan at the University of Cambridge, confirmed carbon-bearing molecules, including methane and carbon dioxide. This supports the Hycean world theory, a water ocean under a hydrogen atmosphere. But the truly electrifying part was the possible detection of dimethyl sulfide DMS. However, and this is critical, the scientific community, including the team that made the discovery, urged extreme caution. The detection has a 3 sigma significance, meaning a 1 in 300 chance it's just random noise. For a confirmed discovery, you need 5 sigma, a 1 in a million chance of being random. We are not there yet. Professor Madhusudan himself stated, "It's important that we're deeply skeptical of our own results. Even if the DMS is real, we can't be certain it's from life. K218b is not Earth. Unknown chemical pathways could exist. K218 billion is not a confirmed world with life. It is an incredibly exciting mystery, a clue that demands we look closer." Now, for the source of the 99.7% number, TWA7b, as we know, it has nothing to do with life. It's the statistical confidence that the object is a planet. So what kind of planet is it? Better than Earth? Not even close. TWA7b is a gas giant with a mass similar to Saturn's. It's not a rocky world you could stand on. It orbits far outside the habitable zone. This planet is not a candidate for life, but that doesn't diminish the discovery. It was a technical masterpiece. It was the first time JWST discovered a planet using direct imaging, and it's 10 times less massive than any other planet found this way. This proves the technology on Webb is even more sensitive than we hoped. The lead author, Dr. Anne-Marie Lagrange, noted the planet was found exactly where models predicted it should be. This confirms that planets are the sculptors of their solar systems. TWA7b is not the destination. It is a vital signpost on the journey. telling us we are on the right path. So where do we go from here? The future rests heavily on JWST, and one system stands out: TRAPPIST-1, just 40 light-years away. It's a cosmic marvelous system of 7 rocky, Earth-sized planets. At least 3 are in the habitable zone, making it the most promising system we know of. JWST has already begun studying them. Initial observations of the innermost planet suggested it was an airless rock, but more recent data complicates the picture. It could be a geologically active world with no atmosphere, or it could have a thick carbon dioxide atmosphere. The answer is we don't know yet. The search for life will not be a single eureka moment. It will be a slow, methodical process of gathering evidence piece by painstaking piece. Beyond Webb, NASA is already planning the Habitable Worlds Observatory, a future telescope designed to take direct images of Earth-like planets. As we build these incredible machines, we are forced to confront the profound implications. The discovery of even microbial life on another world would forever alter humanity's perspective. It would mean that life is not a unique miracle, but a common, perhaps inevitable outcome of the laws of the universe. It would connect us to the cosmos, proving it is not a sterile void, but a living, breathing universe filled with endless potential.